Let us now study application of capacitors. The first application is a camera flash. Now let's see the book here. On the left side, this is a battery, but this is a capacitor. This capacitor will store the charges and will produce a flash. A flash needs large amount of energy, so it takes some time to store charge, and it will give a flash there. So these are very popular in digital photography. Now let's see next one. The next one is heart defibrillator. Okay, let's study what's meant by heart defibrillator. Now you see a capacitor will store charges in this machine. Okay, then at a given time all the electricity will pass to the parallel. See, there are two metal plates. It's kept at the patient's chest, and then a large electric field is given so that the heart will start beating properly. Okay, so in the textbook they given us the capacitance value here is 175 microfarad of this plates here, and the voltage given is 2000 volts. You do the calculation and see. Okay, half CV square, and you'll get around, you can see that's 350 joules. Okay, half into C is 175 in 10 power minus 6 and 2000 square. The energy stored is 350 joules. It's used to make the heart beat properly. Let us see third use here. It's used in the engine systems of automobiles. Okay, that's the ignition system. You can see it's used in the ignition system of automobiles to reduce sparking. Then what does it do? It reduces sparking here. Okay. Then next one we'll see, it's used to reduce power fluctuations in power supplies. Okay. So it reduces power fluctuations. In power supplies, and then to increase the efficiency of power transmission. Okay. So you can see we can have a cell phone charger and all. So in a charger or any eliminators, to reduce the power fluctuation we use a capacitor. It also reduces power losses in transmission. We'll study in higher or next chapter, other coming chapters. Then one more thing they say, a disadvantage. There is a disadvantage also. Okay. So what is the disadvantage? It retains charges. Okay. Retains charges even after disconnection. Even after disconnection from the battery. Disconnection from the battery. So what it can do? So even though you take out the battery, there will be some capacitance on the, or there will be some charge on the capacitor. So when touch it, it may cause a shock. So it can cause a shock there. So you must always discharge a capacitor before touching it. Okay. For example, even if we switch off a TV, okay, still there will be charges inside the capacitors. So we should not touch the back of the TV to prevent shocks.